Welcome back to Gait part 2. In the previous part 1, we had seen that Gait is purposeful, and to achieve the purpose, we move in an environment. The environment throws challenges, and the body system overcomes these with ease. So we understood how does the body system work and what parts of nervous system come into play in order to achieve this. In this part, what we are going to do is we are going to see how does a basic gait progression happen and the reason for the basic gait pattern. Now, what do we define as progression is the ability of a person to move from one point to the other point. So we start from point A, we keep moving, that's the constant gait pattern. Finally, we stop at a particular point. So that's what is progression, right? So many a times before starting this, I would like to tell that many a times when we are in rehabilitation, when we want to treat a person who is having a walking abnormality, say for example a stroke patient or a Parkinson patient, we continuously keep giving a input that their walking is not right, and we tend to correct their walking by focusing on a particular joint which is moving abnormally. Say for example, we tell that don't abduct your hip, try to pull your feet up and dorsiflex it. These are the consistent commands we give, and we expect the patient to move ahead, right? But to this point, I would like to tell, is there a logic behind that? Simply because a muscle doesn't work and we tell that, does it immediately start working? Do people change the pattern of walking immediately once we give a command? These are things which we need to really think, and just listen through this whole part in order to understand why such a manner of giving a guidance to the patient might not be the best way of improving that. Not only that, it's not the best way, it might also be that we might be wrongly guiding them in their walking. So let's go on and see how the progression happens and how it's controlled. All right, so now when we say a progression, we are not going to look now into the initiation as well as the termination part of it. I had kept it for the next one, but in this we are going to just see about the progression. What I mean by progression is different from initiation and sustenance is, in a progression, okay, we have started walking, and the rhythm of walking is continuous, right? Your stance phase, swing phase, it keeps alternating one after the other, right? So let's start by asking a basic question. What are the two ways in which any object, say for example a chair, can be moved from point A to point B? Now, yeah, I want you to just think over that. Okay, you need to move a chair from one place to the other place, right? So you would have correctly guessed that either you need to lift and keep or you need to pull it, but the two ways in which we can do is, one is by pulling, the other one is by pushing. So a chair is right. So our body is like an object in one sense, in that if you are not going to apply a force in order to push the chair to the other place or to pull it to the other place, it's not going to move. Similarly, if your feet is in one place and if you're not going to lift it and keep, right, in order to lift it and keep itself, you would require a force to lift it and keep. So what are the forces which are acting on the leg in order to lift it and keep? So there are basically two means by which the feet moves forward. One is called as a push-off, and you all are familiar with this. At the end of the stance phase, the feet will be, especially your feet, will be going for a plantar flexion. And this plantar flexion is brought about by gastrosoleus, and this helps to push the leg forward, in fact to lift the whole leg and put it forward. On the other side, right, so that's the gastrosoleus. And on the other side, there is also a pull-on force which is brought about by flexors of the hip. So when your hip flexors, your iliopsoas are going to act, it's going to basically lift the leg up and it's going to move it in forward direction. All right, so both the push off and pull on, right, can help in taking your leg forward. How we saw that in order to move a chair, you can either push it or pull it. Similarly, these both mechanisms are happening, these movements are happening, and this both muscle works are happening in order to move it, right? So this is what happens in each and every step as you're moving. So when people saw the muscle activity, and they had seen put electrodes in the muscles, especially the hip muscle, the knee muscle, and the ankle muscle, and they had captured the electromyographic activity, and also they had seen the kinematics of it, and they have derived the powers of joint movement. What was very beautiful about this graph is the hip flexors you see on the first part on the left side, and the ankle graph which you see on the right side. You can see a similarity in between them. Both of them at approximately 40% of the gait cycle, they are the lowest, and then they start increasing. This is the portion on the left when hip is going to flex, and the leg is going to move forward. We are going to take a step. That's the 40% of the gait cycle. You can see that at the same time the ankle, that is your gastrosoleus, also works. So it is not that the push off and pull on are two different phases, but they happen synchronously in a person who is normally walking. So how is this synchrony brought about? And in order to understand this, we need to understand first what are the forces that are going to support in bringing about this action, right? We saw that one of the force is going to be the muscle activation force. So what I want you to do is I want you to think for a minute and tell me what forces do you think are going to act in order to give this push off and pull on. What other forces do you think are acting? I'll give you a minute's time to think. Okay. As you rightly thought, it's I hope some of you would have guessed the answer. It's the ground reaction force when you're going to push off, for example. So when your feet is flat, and in the next phase after the mid stance, when you're going to your terminal stance, what happens is the gastrosoleus muscle, when it contracts, it's going to exert a force on the ground, and the ground is going to give you a push-off force in order to lift the feet. So that is one of the force. But what we also should not forget is there is another force which also acts along with that. Okay, right? That is the potential energy which is brought on by the elastic forces. Now, if you look into the first picture, this is the picture when your swing phase is just going to start, and if you see the last picture, that's the picture when your stance phase is going to end. So when your stance phase is ending and when you come to the swing phase, the initiation of the swing phase, we very well see that your hip flexors are completely stretched during that terminal stance phase of that leg. So once your hip flexors are stretched, what happens is they store a lot of potential energy inside them, like how you pull a rubber band, the rubber band is going to give you a force in order to pull it back. So it's going to give that. Now, not only this, in your ankle. At the same time, what happens is you're having quite an amount of dorsiflexion, and it's just going to plantar flex, and at that moment your gastrosoleus is maximally stretched, and in reaction to the maximal stretch, when it's going to get activated, the potential energy which is stored because of pulling the elastic band is going to come in, and it's going to help in increasing the amount of push which is going to happen in your feet onto the ground. Okay, right? So during your initial stance phase, you're having a lot of dorsiflexion, your gastrosoleus is stretched, and during the terminal stance it's going to get released, and it is going to help in pushing the ground. So together these forces act along with the muscular force and ground reaction force in order to lift the leg and keep it up. So we saw that there is a coordination of forces, and also there is coordination of muscle activation across the joints. So how is this coordination brought about? That takes us to the next component of how does the brain control the gait symmetry. For a very, very long time, people were thinking that individual joints are activated separately by the brain. That means if you want to take a leg and keep forward, the dorsiflexors are stimulated separately, and your hip flexors are stimulated separately, your knee flexors are separately stimulated. But very early on, people found that the brain activates the muscle in synergy. For example, all the flexors are stimulated during swing, and all the extensors are stimulated during stance. So these are called as flexor and extensor synergy of the lower limbs. Now, in around 1911, there was a person called Graham Brown. What he did was he was primarily a neurophysician. He was trying to look into the spinal cord and see what's happening in the spinal cord, what are the connections which are there in the spinal cord. And he identified something called as a central pattern generator. And he said that the stance and the swing phase and the repetition of the stance and swing phase in each gait cycle, and as we keep walking, comes about because of a selected set of neurons and their connections in the spinal cord. So how do they look like? So when you talk about a central pattern generator, there are going to be three groups of neurons. One is called as a premotor neuron, which is not part of a central pattern generator, but that helps to stimulate. The other one is a motor neuron, which is going to be responsible for activating the flexor muscle group, and a motor neuron which is responsible for activating the extensor muscle group, and then an interneuron. We will see a more clear picture about it, right? Now this central pattern generator primarily has been thought to contribute to alternative rhythmical movement of the leg, and this was found to happen automatically irrespective of the central command once a gait is initiated. Now, what are the components of this CPG? So you can see that on the picture, the top portion shows the spinal cord, cut section of spinal cord, and the schematic diagram of it, where you have a central pattern generator, you have a flexor group of neuron and an extensor group of neuron, and in between you have two interneurons which primarily connects the flexor and extensor neurons. So what happens? Let's look into it. The first is a extensor half center. So when this circuit is activated, we'll come to it what activates it, but when this circuit is activated, it first stimulates the extensor neuron. This extensor neuron has a direct connection to extensor muscles of the lower limb. In addition, it also has a collateral branch which goes and stimulates the second interneuron, which is the bottom black neuron which you see. And once the bottom black neuron is stimulated, what it does is it goes and stimulates the flexor neuron. So you have primarily in your central pattern generator, you have 4 neurons inside, and you have an extensor half center and a flexor half center. Right? So the extensor half center is responsible for the stance phase of gait. right? So what happens here is whenever you're going to place your leg on the ground, the sole of the leg and the pressure receptors there are stimulated when the feet touches the ground. Once this stimulation happens, that additionally acts as a stimulation for the extensor half center. So primarily your extensor half center, the extensor neuron is stimulated by the interneuron and the central pattern generator, but additionally when you give a load onto your leg, automatically this information goes and stimulates the extensor half center. So you need to understand that there are two stimulus, one from the within and one from outside, which goes and supports it. Now the flexor half center is stimulated when you're during the other phase. So after the extensor half center, the interneuron which goes to the flexor half center stimulates the flexor half center. There is a direct connection to the flexor group of muscle and it gets activated. It also has a branch which goes to the other top black color neuron, which is an interneuron in the central pattern generator. This activates the flexor part of it. But in addition, like how we saw in stance phase that peripheral inputs go and stimulated, there are also inputs from the periphery, especially the hip joint position and the unloading of the stance limb, that is the stopping of pressure input from the feet. Both of it is suggested to activate the flexor half center. So you have primary circle which goes on and additional inputs from the periphery. So once one neuron is activated, say for example the extensor neuron is activated or the top neuron, interneuron is activated, that stimulates an extensor stimulates the other interneuron, the other interneuron stimulates the flexor stimulates the other interneuron. So it goes in a cycle after cycle, and the interneuron determines the gap between these. And it's not necessary that we have a huge amount of nervous structures which have to control each and every muscle. Basically, this central pattern generator is thought to bring about a rhythmic movement of the lower limb. And not only in humans, these pattern generators are also found in animals, and in certain other rhythmical activities also is thought to be controlled by the central pattern generators. So I hope by this time you would have understood what is a central pattern generator and why this simple architecture could help in bringing out a rhythmic movement. So the question is, what activates the CPG? There is a region in the brain, in a midbrain, called as mesencephalic locomotor region. This region is found to have direct connection with central pattern generators in your lumbar spinal cord, and this is they think that this is when we think about a gait, I need to start walking, then the brain can be stimulated, and in one go it can come and start stimulating the CPG. Now, as we saw that it's not only the CPG functioning, also sensory inputs from the periphery also go on and help in producing this rhythmical pattern. So by this time you would have understood that whenever we are walking, our walking is so uniform. We have a stance phase and swing phase, and there is a specific relation between the stance phase and swing phase. It is not by individual activation. We saw that intrinsically the body system, that is your muscles, coordinate within your limb, forces coordinate within your limb, but in addition your neural inputs also come and help in producing a rhythmic pattern. So all these together helps in our progression of walking. I'm not going to cover about lot of other things which you would basically be able to read from your Cynthia Norkins or the other books about each phase, what is a muscle activity and everything. So primarily you need to understand that if your leg has to move, there has to be a force, and what produces that force is what you need to understand, and how is it controlled. So next time when you see your patient, if you're going to actually try and give additional input, say for example dorsiflex more or don't abduct your hip, it's going to act as a hindrance to the smooth rhythm which is produced by the central pattern generator. So that's why whenever we are trying to correct a gait, we should not be looking at individual joints. We need to looking it in total. And so with this, I complete the second part of the gait. Thank you.